So for tonight's homework, students are going to continue to work with fractions on a number line, and they're going to think about where numbers are in comparison to each other. So what I'd like students to do for this to help them kind of get an understanding of where the number should be is to make the number bond for each fraction. So the number bond consists of the number itself, in this case the fraction, in the top bond, and then showing two addition models underneath. The first one is always going to hold what equals one whole. To know what equals one whole, you're going to look at the denominator of each number. So in this first case, it would be 2 out of 2, and then we're left with 1 out of 2. You'll notice if I add these two together, I get back my original fraction, which is 3 over 2. The other thing that students can then do from here is make this into a mixed number. This first number will always equal one whole because it's the 2 over 2, or the fraction that's equivalent to one whole. And then I can add in the remaining fraction. So I've taken 2 over 2 and changed it to one whole, and then added together with that the half. That tells me that this fraction A is going to go here. In the next one, I can think of 9/5 the same way. I can take 9/5 and make the number bond. Remember, the first part of the bond is going to be what equals one whole. The denominator helps me know that. It's 5/5, because 5 makes the whole based on the fraction. That leaves me with 4/5 remaining. This I can check by saying these two numbers add up to 9/5, and then I can make that mixed number the same way I did on the first one. 5/5 is going to be equal to one whole. 4/5 is what's equivalent. Now, to figure out where that goes on the number line, what students can do is they can make fifths out of the number line between 1 and 2. So I know fifths means I have to take the whole distance between 1 and 2, break it into 5 equal parts. So I'm going to do 1, 2, 3, 4, and then I know 2 would be 1 and 5/5. This is something that we worked on in class today. So if this is new or unfamiliar, your students just did learn it today. So this will be 1 and 1/5, 1 and 2/5, 1 and 3/5, and then right here is where you'd plot B, because this is 1 and 4/5. So you can mark B on the number line there. Okay, then I'll come down here and do C, which is 14/10. Again, I want to do the number bond first. So when you do the number bond, remember you're thinking about what makes one whole. One whole is going to be 10 over 10, which leaves me with 4/10 left. Well, I know that this is going to equal one whole and 4/10. So I'm going to do the same thing. Now I've already done fifths, which I can make equivalent tenths. So I know if this is 1/5, the equivalent tenth would be 2/10. So this is going to be 1 and 4/10. 1 and 1 and 6/10, 1 and 8/10, and then of course 1 and 10/10. So if I'm looking for 1 and 4/10, I can see it's right here at the 1 and 2/5 mark. They're the same, so I can then mark that C. On problems for number 2, they can again use that number line, or if that one's getting a little crowded as mine is, they can make a new number line. And they can just call this again 1, 2, and label 1 1/2. These fractions, as you can see, are already in mixed number form. You can see the whole number 1, and then the fractional part 1 and 1/6, 1 and 4/12. To find these, or to make these fractional parts, you're going to use the denominator to know how many equal parts you're going to break the line into. So I'll do part A, and then the student and you can work on part B. So I need sixths. Well, I already know the equivalent fraction in half for sixth would be 3/6. So I need to find 1/6, 2/6, this was 3/6, 4/6, 5/6, and then I know this is 2 and 6/6. So this is going to be 1 and 5/6, 1 and 4/6, 3/6 I already have labeled, 1 and 1/6, and then 1 and, oops, that should be 2/6, and this should be 1 and 1/6. The next fraction I see is 4/12. Well, I know I can make equivalent fraction from 6 to 12s, because if I think about 1/6 making it into 12s, I just multiply both the top and bottom by 2, and I get 2/12. So I know this is going to be 1 and 2/12, 1 in 4 twelfths because 2 doubled. This is going to be 1 in 6 twelfths, 1 in 8 twelfths, 1 in 10 twelfths, and of course 1 in 12 twelfths. Again, these number lines get a little crowded, but that's okay. So I can see here my 1 in 1/6 for my original number A, or letter A, is here. And then I can see the 1 in 4 twelfths was right next to it at 2/6. So I can determine that this number is less than, because I can see it on the number line. For question 3, students are going to do the same thing. They've already have some plots available, and you can see this is going to be the 1/4. So this is a good way for them to understand and to mark the area too. They can find those equivalent fractions. So for ninths, of course, they're going to want to cut this into 9 equal parts, fifths, 5 equal parts, and then for 15ths, 15 equal parts. Okay, and then what they're doing on the back is they're writing greater than or less than. They do not need to make an explanation of why they think that, but if they do use a number line, that can help. So students would use that number line if that's helping them, or if they can compare it maybe to half, or give another reason to why they would do that.